we have to figure out why regenerating clusters is so slow, because it has to run at full frame rate. Like, if we're taking a video, it has to. So let's take a look. Let's take a little peek. Do a perf. Can we just do like a little perf record dash d call graph is dwarf? That'd be kind of cool. And then go down here and start just like sliding this shit around and seeing like, you know, what the fuck is going on. Just like, you know. Looks like a lot of time is being spent in like clustering algorithm management of, how do I say this? Like, which points are in which cluster. We're like keeping track of that, and that's probably a bug. Like, or not a bug, but like we're probably just doing something like fucking stupid. So we kind of just like hand rolled a clustering algorithm the other day. It's like loosely based on dbScan. The idea is we look at all gradients in our barcode, right? So can we not run perf right now? So we take this barcode, we convert him into a bunch of gradients, right? So basically the colors here represent like the direction of the gradient. And we're hoping to find a barcode by kind of saying like, if we have a bunch of gradients that line up, i.e. like we have like a lot of stuff that have edges kind of in the same direction with each other, then we can like kind of like put those together into some clusters, right? The threshold here is a little bit wrong, so there's like a gap in the middle, probably because the resolution that we picked was a little bit, we've like lost some information by the fact that we like resized too low, right? So like this barcode is supposed to have some stripies in here, but it like kind of got so blurred that it's just gray. So this thing is like turning into two clusters, but it's supposed to say, hey, if everybody's lining up, we're chilling. And I think the way we do that is we like iterate pixel by pixel, look at nearby pixels, and we say if their angle, if their like gradient direction is similar to ours, and the gradient is large-ish, we are the same cluster. That's what we're trying to do, right? Now, because like there's like if neither of us have a cluster ID, make a new one. If our cluster IDs are different, merge clusters, right? Because like an extreme example of this is if you had a shape like this, right? And you are sliding over this way. You might have like a cluster here, right? All of these guys are kind of similar. And then you kind of like go like this, boom, 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 boom. And then you see like a bunch of guys lining up over here too. Now, if all of these guys all line up down here, eventually the like ones are going to keep like 1, 1, 1, 1ing, and the twos are going to keep 2, 2, 2, 2ing, right? And eventually they're going to collide. And we have to like merge this together. Now, I don't think that should be happening in barcodes, but it does seem to be. So I don't really fully understand why. I think it's like probably that like we're iterating a box of pixels and we're like looking always top left to bottom right. And then maybe like, you know, if you have like a line like this, maybe you've seen like, maybe you're seeing like two parts of something, you know, early. I'm not really sure. Like maybe you see like this and this, but not something else. Like not, I don't know. Right? It could be something to do with the way we're ordering. So we are seeing that we have to merge clusters together sometimes. And it looks like the way we are tracking like how to merge is probably what's taking up all the time. I'm just assuming because that's like the only hash map that we have. And if we like perf report here, it is very like, hey, you're spending time in a hash map of 0.2Ds. So seems likely. We could also do a little like perf script and look at it in Firefox Profiler. Firefox profiler. What is it? You can just like load stuff in here. Boom, get a little picture, which, you know, maybe we can just get a little extra confirmation. Dude, can you fucking show me folders sorted first? Why is it like this? What is this sorting? This is not by name. I guess it is. It's just I usually want folders first. Barcode scanner, and then we're looking for test perf. Here. So we want like how do I know when it's like where it's expensive? Right, like I want like when we were doing a lot of stuff. A lot of like OpenGL stuff. It's finding. Am I like 3 out of 8 tracks? Can you show me everything? I mean, it could be that like a lot of the time is spent in OpenGL stuff. Or did I oh, I didn't fucking I think I ran and I think I fucked up somewhere. Okay, so maybe like 3 seconds in, I start like sliding this shit around, and here it's starting to look really bad. Really bad. Okay, close. Perf script. Let's reload this thing, make sure that this is correct, because I don't feel like it was. Okay, so this is a 10-second profile. I don't understand why, like, if I call perf report here, I'm seeing, like, hashing stuff, and if I look at this, like, trace in Firefox, I'm seeing, like, OpenGL bullshit. Like, why does this look different? Am I crazy? I feel like I'm losing my fucking mind. Yeah, that's confusing. I'm used to this tool being like pretty decent for this. Yeah, it's like all OpenGL. What the fuck? Why is it different? Why is it different? I guess maybe like most, like it's only doing the expensive stuff every once in a while or something. Like, yeah, I'm confused. I'm confused. Maybe, I mean, it could be OpenGL stuff. Maybe. It just doesn't really make sense. What does perf script even do? What am I looking at here? Like a text representation of this thing? Of like samples of stuff that happened? Is it like literally punching out every single sample? Interesting. Is it looking at a GL driver? That's what I thought. But I didn't see a way to like see some. Oh, maybe test like maybe the perf script is exporting a single thread or something. Because like here we have like more stuff to look at, but like none of these threads seem like the one. Like all of these guys are starting like extra thread starts. This is the main thread here. Yeah, it's just so strange that like none of these function calls are mine. This This is all OpenGL shit. It's just kind of weird. I wonder if like the profile's too long and it's only looking at like the first little bit or something. I mean, it thinks it has stuff over here. Yeah, it looks like there's like, I don't know, there's something wrong here. I guess we'll use the command line. Right, because here it's like pretty clear what's happening. I wish that I could, can I like turn on and off? I don't want to see like this like 13%. Like this is like for the whole runtime of the app, and there's a lot of times where we're not doing this shit. I want to know a little, like at the very least, like it has to be this stuff, right? Std debug. It has to be like when we are applying an action, like that has to be where the time is coming from. So we have like a kind of like an entry point to look at, right? Obviously, if I start like sliding this stuff around now, it's like fine. So like it does have to be in here somewhere. I guess like theoretically it could be from image view updating, like OpenGL stuff. I guess there is some OpenGL stuff in here. We could do this and just kind of see if it's less slow or more slow. I assume that it's still shit, but I guess like it would be reasonable if all of the time was coming from actually like copy pasting the stuff into OpenGL land, which it's not. It's not. It's very clear it's not. So I don't know what the fuck that profile was doing. Okay. So it would just be nice if I had like a more targeted view, but I mean, it's pretty clear that we're spending stuff hash mapping. So can we annotate this function? I want to like, can I don't want to look at assembly, but I guess I kind of have to. Okay, I mean, I guess we just bisect. It's pretty clear to me that it's this. Pretty clear to me that is the clustering stuff, but we can just confirm. Yeah. This, no matter what I do, obviously has no effect. So this function is causing the problem. And I guess like if we wanted a more targeted benchmark, we could just do a benchmark where we run cluster image gradient like 10 times in a row and see where the pain is coming from. But whatever. Okay. So this function needs some love anyways. Because this is a fucking disaster. Look at this shit. What a disaster. I guess we should just do this. We can just do some like manual timing checks. What? We do like timer push, you know, mark start of like some name. And I guess we say like here we like get the time. Init here does something. Maybe it's like mark end. Mark start. Yeah, sure. Then here we have like a list of times, probably. Dude, I don't know, man. Time, stood, time, instant. And then, name this. Fuck it. Array list is fine for now. A little bit of leak or wasted memory, but whatever. Item like times is this. And this is like this returns a timer. Var ret is this needs an allocator. Or maybe this is like you could do this like on stack. You could do this max elms, right? You could do this. Then you don't need an allocator, which is kind of nice. Fuck it. Sure. Var, what is this? Like, there's like bounded array. There. Huge. Can we do this? Default initialize this guy? Surely. Surely this guy can be default initialized. Yep. Mark, start. Okay. Easy peasy. And we have like times append. Name is name and time is now. Huge. Okay. No allocator. Okay. Then here we're like mark start. Clustering. And then like down here we're like thresholding. And then we can log at the end. Easy. Okay. Lots of mistakes in here. Okay, so for 0 self times like something like this. We check you know, times I I guess we do this. Now is this. Okay. And I guess we can actually do this. Self, mark, start, end. It's a little cheat to make this loop below work okay. We say look at times I. End is times I plus 1. Easy. And we just log, you know, this took this milliseconds or something. And we look at start name, and we look at like end time minus start time. We can't do that because these are instants, so it's like since as nanoseconds. So it's like N times since start time divided by nanoseconds per millisecond. Elapsed ms is this. Boom, 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 boom. All right. Seems straightforward. Okay. Fuck. The fuck is this complaining about? Expected type found this. Oh, fireball. True. Logging to be tribal. True, huh? True. True. And then we didn't make it big enough. We didn't make it big enough. All right. New lines, I guess. All right. Yeah, okay. So it definitely is the clustering step, which is not a surprise in the slightest, right? Really not a surprise. But it's good to be confident. Okay, so presumably it's because like the cluster, we're probably just making like too many clusters. Then like this hash map is getting like fucking mega big, right? That would be my assumption here. Every time we put a new things in the cluster, can we do like cluster list like count? We should probably new line, huh? Probably. Yeah, so this is getting like, 2,000 elements. Which shouldn't really be that bad, to be honest. It would be nice to kind of attribute which of these segments is taking so long. Right? I assume it's merging. I assume, but can we actually make this like a map? B-tree maybe, it seems like the performance of the hash function was blowing things up. I think that probably we can simplify this problem by... I assume it's more that like the idea of using a hash map for this cluster list and merging them is like fucking stupid. I think that's probably the problem. I don't even have to think about it that hard. That's gotta be it, right? It's just that like we're spending so much time in here. So we have to think about how can we solve this problem more intelligently? Right? It's probably that we're like visiting every pixel like so many times. I would like to see how many times we are visiting any given pixel. Or like maybe even like num pixels visited. I assume that this is like very high, right? So here, every time we visit a pixel here, num pixels visited plus equals 1. So this is like we're visiting, each pixel as we iterate across the image. Then we're looking at, the adjacent pixels to us, right? Then when we are merging, we are visiting their pixels again, right? So when we're like merging clusters, we're like setting in the output cluster map, like their pixel needs to like match ours. And then I think that's probably it. So can we like log how many, like what is this? Like order of magnitude. Num pixels visited. I assume this is just like fucking dumb stupid high. Yeah, like 400,000. How big is this image? What is this, like, how big is the image we're looking at? Rotated. This is 248 times 140. So this is 34,000. We're looking at each pixel. That's actually only like 10 times. Which is, don't get me wrong, a lot. But not as many as I thought. You can like look at each pixel once though. Like we can definitely look at each pixel only one time, I think. Is that true? I think so. Because I think that if you just like rip this shit as like a depth first search, just because you're looking at a 5x5 region around each pixel, I think I'm not even. Yeah, maybe. If I take this out, so like let's like not look at the merging steps. Yeah, it does seem like the vast majority of this. Yeah. Yeah. I guess this merge step is not really eating that much time necessarily. Well, that is adding like maybe like another like 50%. But you could like just do like depth first search, right? Like you could say like what we're doing right now is we're like going like boom 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 and like looking for a shape in here and like adding to that shape as we go, right? And then like writing down as we look at each pixel like which cluster it's part of and then like merging those two if we collide. We could do something different where you could go like boom boom. Basically like say it was like a really easy to bisect image, right? You could start here and like kind of just consume all of this by like looking at your neighbors and like, you know, walking all the way around and then like keep scanning, be like, oops, I've already hit all these. And then do this. You hit here, walk all of this stuff. And then keep going. There you're like probably hitting each pixel twice. Raycast? I mean, it's not that simple because we're not actually clustering based off of like edges. We're clustering based off of like whether or not we're close to guys that have gradients that are working in the same direction as us. I do feel like there's like a way to make this thing fast. I think that the we have to think about if there's a better way to if there's like a better way to make sure that the shape we're hitting, like that we're building it the cluster the right way, right? We're probably like doing a lot of merging that we don't have to do. I don't like, even understand why we have to merge, to be honest. So let's think about this. We have a box that looks like this, and we have a square that we are sweeping over it, right? So like presumably we have seen all of these pixels so far, and so now we are kind of running a kernel over here. We hit this pixel right here. Drawing a box, you know, that like kind of like overlaps with above. Now, the question is there a way for us to end up with like a new cluster ID here? I feel like we should be like looking at these pixels, right? We should be seeing like this pixel and this pixel and being like, oh shit, we now I am part of this cluster, and then I should be like propagating that to all of these guys down here. This feels very graph searchy. Yeah, I think it is. I think it is. Almost a flood fill. Yeah, I mean I agree. Well, I think the flood fill way is you would do like a recursive search, which like I think is like fine, right? But I just want to know if there's a way to do this. Like, I'm trying to like imagine if there's a way I can do this like single pass. I think there's like something where we're looking in both directions when we don't have to be. That's kind of how I feel. Is like we're wasting time checking symmetrically, which isn't great. Right? If when we look at this pixel, we are checking, you know, everyone below us to the right. Then like when we get to this pixel, we don't have to look up and to the left anymore, right? Because we've already seen that. So I think there's something there. Um Yeah, dude, just like thinking about a box is so hard. So, how do we make sure that as we go single pass, that we hit every single pixel that is within some distance of us? That's what we're looking for. We're looking for things that are 2 to the left, 2 to the right, 2 up, 2 down, right? There's some sort of symmetry here. So we're basically trying to say, is any pixel... Yeah, I feel like you just cut off almost all of this is unnecessary searching. I feel like all of this is not necessary. Because if I'm iterating here, 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 I don't have to search left because I searched right from where I was there before. And if I'm going down, I don't have to search up because I searched down from where I was before. Yeah. So there's some extra counting going on there. Let's see if I can just not do this. So when we do input area iterator, can we go like area iterator start end? Left X, left Y, right X, right Y. Okay. So this is literally just like left X. I guess like we want start X, end X, start Y, end Y. Is this inclusive? Probably not. Okay. So we want starting here, ending at itx plus 3, ity plus 3. Okay, then everything else I think just keeps working, and that should reduce like the number of pixels visited by a lot. But it's obviously not, right? The fact that this looks different now means that I'm not understanding something. Yeah, I don't know what I'm not understanding though. Interesting. Interesting. Because I would think that this has absolutely no difference from looking up and to the left. And because like the fact that it does means that there's either a bug somewhere below or I haven't pictured this algorithm correctly. Okay. So maybe we first of all, also we can get rid of some of these like double nested loops, which will just help my brain a little bit. So this should be next pixel as well. Sure. Okay. So, was the diagonal farther before or something? I don't think so. Um. Okay, maybe we just have to like think this through. So I iterate over these guys and I say, hey, this is my pixel, this is my cluster. If my gradient is too small, I ignore it. Sure, that makes sense. Then I'm like, okay, look down and to the right. As I look down and to the right, can we just make sure that we have like sibling, pixel? Can we, I just want to make sure that I understand what's happening here. And then like my pixel. Oopsies. Oopsies. Can we new line as well so that we don't like fucking lose our minds? So make sure this is doing what I expect it to. What in the fuck? What the fuck is happening here? Oh, because we're continuing. My bad, my bad, my bad. My bad. Okay. So I'm looking at 3485. And I'm looking at 3437. Doesn't seem right to me at all, huh? Got the parameter order this wrong? I'm a dumbass. So now it's like 97,104, and I look right. Why am I looking at 96,105? That's a bug. If what am I looking at here? So if our iterator x is less than start x, that seems fine. What the fuck is going on? 78,104. So I go 78, 79, 80. Then 78, 78, 79, 80. So how the fuck is this happening? How the fuck is this happening? I'm calling next pixel. I'm going after next row. We're going to start x minus. We're supposed to call next call here before doing anything. That's why. That's why. Okay. So now we have 42, 93, we go 42, 43, 44, and then the next row, 42, 43, 44, next row, 43, 43, 44. Okay, cool. Cool. This guy is now mad, though, that we're, like, ooming. Which is not super expected. Can we stop printing so much? Okay, so good news is, like, if we crank this up enough, we are back to diagnosing this somewhat correctly. Now, why were we ooming, though? Just because there's, like, too many clusters, I assume. And also, interestingly, like, num-pixel visit, I'm not really convinced that it's, like, down by that much. Okay. So, I kind of feel like that, like, merging shouldn't happen very often. And if it is, then why? I guess because we're not hitting every... Let me think for a second. I think I understand. It's this case. It's this case. So we come in here. We like are scanning like a box like around this size, right? So we probably like mark this as one cluster, then keep going, mark this as another cluster, and then I guess we need to draw these lines close together. Like there's probably something where we've like marked, you know, adjacent pixels here, and then eventually I thought that was it, but maybe not. Mark these. Then at some point where like these have to get bridged, maybe was what I was thinking. But that doesn't seem to make sense. Is UM a really common failure mode for competition heavy programs? Well, I'm limiting my allocator space really low because I don't want to take up that much memory. I think I just need to fucking visualize this as it's happening. Otherwise, I'm not gonna understand. I don't think there's a choice. Because I'm just like struggling to picture what's happening here. And so a better visualizer would be nice. Which means we have to like refactor this loop so that we can like pull it externally. You know, gradient clusterer. And we just kind of sticker outputs. Since you've thought about this problem a bunch, thoughts on explaining the fact that the barcode is an area with dense, strong line gradients. I think that's what I'm trying to do. Would threshold, magnitude, blur, grad, image create a mask of the area we're interested? More fragile and annoying tunables and clustering though, probably. I missed last stream. Threshold, magnitude, blur, gradient, image. So we're doing this. The blur we tried, and it turns out that by blurring, you're like the thing is low resolution enough that we've kind of done the blurring as like by reducing resolution. Then you're like magnitude thresholding, which we're doing. The thing here is that like this would give you any strong edge, right? And we want edges that have like a big area of alignment, which I feel like is missing from that solution. But you could blur like, yeah, like if you blurred like at the end, maybe. Oh, but I guess by blurring the gradients, maybe we didn't blur the gradients. Maybe we blurred the input image and then calculated the gradient on that. You're saying like, just fucking like blur the gradient together. Well, I think averaging angles is kind of hard. Maybe. But I guess you could like, we could solve that. That's solvable. Maybe. There's maybe something there. But I want to keep going down this path first. Because I want to at least understand why it's not doing what I expect. Might as well. You'd blur mix the 2D vectors. Yeah, I think that makes sense. Yeah, I guess that is reasonable. I think that you're right that might be that. I don't think that's like a bad answer at all. But oh well. Cluster list is, I guess, this. Okay. And then we have our cluster ID cache here. Then we have iterator. So this is a image pixel iterator of gradient. Okay. Then our like step function returns a bool. And this is essentially just the inside of this loop. And we just have to like start slapping self like everywhere that it doesn't like. I guess here we have to do self it next pixel. If this is not true, return false. Okay, min cluster mag. And cluster angle threshold. Okay, and then just everywhere. This is return true. Keep iterating. Boom, 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 boom. Slap some selfs, self. Uh-huh. Keep going. Okay. Boom. Boom. Okay. So now we can, like, create one of these guys. I tried to wait for time, but I didn't want to break the chain of thought too bad. Oh, don't worry about it. I can just ignore if it bothers me too much. I can just ignore. Not the end of the world. Okay. So probably, like, a lot of this stuff comes in here. So we have input here is an image gradient. Allocator here. Okay, and then everything else is just like alloc is alloc. Cluster list is this. Boom. This is like this. Boom. Easy. Wait, what's it pissed off about? I see. This has to be done here because we do have a memset. Num pixels visited equals 0. Visited. And then we're probably missing some stuff, right? But we'll see. Var clusterer is a clusterer in it with the stuff. Surely we have to pass these guys as well. Surely. And then while clusterer step. There we go. Should be something like this. You know, something like this. And then here we're merging stuff, which we'll do later. Okay. Bump. Min cluster mag equals min cluster mag, and cluster angle thresh is cluster angle thresh. Easy. This thing can fail, so this has to fail, and then clusterer init here. Is like this. This goes away. Okay, does it still compile and run? No, because no input. Okay. Yeah, this thing does need to failable, and I think at the end of this we need to return true. To say, please keep iterating, sir! Okay, boom, boom, boom. Okay, so now we should... Oh, wait, this isn't working. Why is it different? I don't feel like we really changed much of anything. All we did was pull it out. So I really don't feel like we should be ooming more than we were before, but... Did I have to, like, change this threshold or something? Oh, yeah, maybe. Maybe it was after we changed the iteration order. These guys needed, like, different thresholds to work good. Okay, so this is still working, and now we can start, like, try to hook up, like, a next button here. So what we want to be able to do is we want to be able to visualize after every single step of the cluster. So how do we hook that up? I guess, like, at the end here, we have some sort of, like, button to push. Another idea, instead of a blur step with cluster, you can do something like box blur, until you do the accomplish this step. So you take 3x3 window of neighbors, up with the pixel with the gradient cosine similar to the neighbor to itself. Kind of blurs the clusters, but prevents selecting any strong edge. Yeah, maybe. Maybe. I just really want to, like... I want to understand why my thing's broken. Is, like... Before exploring other options, we need to make sure that the option that we're doing is what we expect it to be doing. Next, or step cluster. Where's our GUI action? Step cluster. Okay. What the fuck? Oh, it's that the, unhappy with the auto type resolution here. This is be like this. For this to compile correctly. And then somewhere we have to, like, do something when that happens. But we'll get back. We'll get there. Whoa. What is it pissed about? At button. Make button has a click action. Which is an action generator, which we pass to get action. And if it's a struct he calls generate, oh, he's expecting a pointer? Oh, it is a pointer. Wait, what's the problem? He should be returning an action, which is just the point, which is just the click action itself. Why is it mad? Runtime coercion from enum tag type to union GUI action, which has non-void fields. But isn't that fine? Because it's... Oh, I see. So he doesn't know which tag it is, and so he can't coerce into a GUI action automatically because he doesn't know. But isn't generator here already an action? Am I crazy? Like, this should just be like really straightforward. Whoa, okay, so he is a tag type, but I don't think we're doing anything special here. We just have click action as any type, click action comes in here, click action gets stored there. Am I crazy that, like... Type of GUI action step cluster is like... Do we have to do, like... this? For this to work correctly? Or maybe it's like... Like, do I have to put this like this and then do this? No way. Right? Oh, I mean, equals this. I mean, that does seem to fix it. That's fucked up. Yeah, so it looks like what's happening there is, I assume also that this doesn't have to write void here. Yeah. So what's happening there is the compiler, when it sees GUI action step cluster like this, the type of this is like surprisingly not a GUI action. This is a GUI action tag type or whatever, like of GUI action step cluster, right? And then like it's auto coercing into a GUI action sometimes. But here we can't do it that way because this is like taking in an any type and storing it. So it's storing a tag and then trying to coerce that tag at runtime, and it's like I can't coerce always. That's crazy. It feels like something that the Zig compiler should be able to figure out for me, but whatever. Not the important part right now. Okay. So, I think this means that we need like a clusterer here, right? We need like a clusterer that's working outside of this thing. And so maybe the clusterer needs to work. Okay. Debug cluster Sobel is this. And this will live forever and ever. So this runs on the root allocator. Okay. Then, when we step the cluster, we need to like visualize this thing somehow. So what do we want to look at? We probably want to like draw the box. Or just like look at the current output. That's not crazy. That's not crazy. So maybe we'll just render the current pixel in here. Right, so on each next, we like write down what the next pixel we're gonna look at is. Um, yeah, we'll do this. This is fine, so. Not easy, not easy, not easy. Hold on, hold on. We gotta figure this out. We can figure it out. We can figure it out. So we have clusterer is clusterer in it. Maybe we have like a allocators root make sub alloc clusterer. Because we're gonna want to reset this thing sometimes, probably. Okay. We have the input, which is debug cluster sobel. Okay. Min cluster mag. GUI params min cluster mag, GUI params max cluster angle. Okay. Then every time this thing happens, we update the clusterer as well. And we say cluster alloc reset before we do that. Okay. Then when we step the cluster, we say clusterer step. I think there's a lot of things that have to be tried here. Okay. So far, so good. And then we just have to like display this somewhere. So I almost want like a root. What do we like make GUI? Where the fuck is the GUI generated? Make GUI root, here we go. So can we actually have image views have like a debug cluster here? Okay. And then we just want to hold that guy separately, I think. We're gonna update him independently. So this is like image views, debug cluster. The fuck? Yeah, debug cluster. Texture is maybe he needs like his own function here. So this debug cluster, it looks like we have an allocator that needs to be associated with this guy. So we'll have debug alloc here, I guess. Then we have, I don't know, a function that's like update debug with a scratch. I think that's fine. With a clusterer, probably. I don't know. Okay. Debug cluster here, here, and here. Results.clusters is like clusterer.out, I think. On top of nothing? I guess we need this as well. Which is fine. That's fine. And then this is clusterer out image width here. And clusterer out calc height. Okay. Okay, so this should do that. Let's make it so that when we step this thing, for now, it's gonna like rip the whole thing. Just so that we can see something happen. And then we'll say like image views update debug with Scratch. And the debug cluster. So Bell and oh, it's just in there. So we can actually get away with this, just passing the clusterer. Because the debug one is in clusterer input. Okay, cool. Close. This guy needs an ampersand. And this should be debug alloc here. Nice. What's this bad about? He does want clusters here, huh? Does he actually need that? He only has a cluster image, right? I assume. It's like image. I actually don't know. I actually don't know. What is his input? It's a gradient. Okay. Is it? No, it's a U size. Okay, clusters of text. So now this is... Oh, I see. I see. He does need this. He does need this. Okay. Num clusters is clusterer biggest cluster ID for now. I think that's right. I don't know, man. I don't know. I don't know, man. 1729. What is this pissed about? Image. Fine. Fine. If that's what you fucking want. Okay. So now let's set some parameters that work. And then if I hit step, we should see something, but we don't because we didn't actually put that thing in the GUI like a dumbass. Make GUI root. So here we need to push the image views debug cluster as widget. So now this thing should be completely black after we change the thresholds here. And then I hit step and it should show up. Okay. I don't really understand why... Oh, because we don't do the filtering out yet. That's intentional. That's intentional. Because this guy's doing more work than this guy. Okay, okay, cool. Can we like put a fucking label here? Debug cluster view. Okay. So now we should be able to make it so that this step doesn't just like rip the whole thing. Right? But we should be able to actually take a look at what it's fucking doing. You know? So we should be able to be like... Now I'm gonna have to click this a lot of fucking times, I think. Is this bugging out? No. Oh, but this thing isn't, we're not gonna see anything interesting. Okay. So can we make it so that we go like 0 to 100 or something at first? Like, does this concept even work? Okay. Like, surely, right? Step. Um, that explains a lot, right? Like, a lot. The fact that we're going bottom to top, it's like, that's why we have to fucking merge clusters. That's so funny. Why are we going bottom to top? What the fuck? What? No way. I don't believe it. Is it upside? Are we just visualizing it upside down? That almost seems like more likely to me, right? Okay, yeah, we're just visualizing it upside down. That gives me a lot of comfort. Which is fucking stupid. So everywhere where we're like making these textures, they're just fucking upside down. It's just 90 degrees, no? I think it's flipped over the over the y or over the x-axis. Right? I think that this is like mirrored this way. Um because I think that when you load OpenGL images, it's expecting to have the things flipped. Yeah, so I think that we just have to fix that. Can we GL text image 2D upside down? Can we like flip this? Invert textures during pixel transfer. Like a thing you can do? No. That's a little annoying. A little annoying, but it's workable. Let's just do this. We'll just flip it in the renderer. We'll just flip it in the renderer. Or can we just do like flipped? Render texture, transform. We just flip it in the transform, I think. I think that's the easiest way to do this. So in our main, we have our image view who uses these image renderers. He creates these like render texture with a transform. Can we go then math transform? Can we do like scale 1 -1? And then I think everything kind of just fixes itself. It might have to go the other way. Flip first. No, flip after. Where the fuck is this transfer being applied? I think it's flip first. I think it's flip first. Is that right now? I actually don't fucking remember. Oh, yeah, that's right. fuck me. Right? This is the same thing. Yep, okay. Okay. So now, just, can we see anything interesting happening? Right there. Why the fuck did that change? Okay. Can we, maybe we should support kind of changing the step size, and then we can kind of get into an interesting area and go pixel by pixel. How about that? How about that? Update step size. Step size, here we're going to, yeah, take the max, and then we also want to, like, round. And then insta float. Float. Yeah, that's probably fine. I think that the dragger has to be a float, so that's going to make our lives easier by doing it this way, I think. Okay. So can we be like, step size is make drag float with GUI param step size, GUI action update step size, and I guess here we're looking for, you know, something like 0.1 per pixel, and we have to move 10 pixels to up it by 1. Sure. Okay, and then here we should go like for 0 const step size equal to, yeah, u size, and from float of GUI param step size, and then we go boom. All right. I don't know what they do with commercial handle barcode scanners, but they work really well, even basic single line ones. Yeah, I think that they get to use a laser, which is kind of hype. You know? Makes the game a lot different. And I think they get to move a lot faster too. Since I'm doing it from my phone, you know, I don't think I'm as lucky. Okay, I think this is doing what I expect. So I like bring this up to like 100 or like even like 150. Bring it all the way up to like, okay, yeah, cool. So bring this thing down to like 25. Look till we're like kind of in the middle, and then we go pixel by pixel. Expand a little bit, make it bigger so we can see. Okay. So he's going pixel, 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 pixel. It's like really hard for you guys to see. Oh, he's merging. I'm seeing him merge up sometimes. Why is that happening? Also, let's I would love to not render this with the magnitude for a second. Like, can we just do if true mag equals 1.0, just so we can see the which cluster things are in a little bit easier. Okay. Go bigger. Okay. So we're kind of like in the center there a little bit. Can we bring this down to 1 now? Where? Okay. Okay, so we're like here. Yeah, I don't understand how it is ever changing the color of something above it. I don't feel like that should be happening. Oh, maybe the color of the thing above isn't changing though. Because oh, it might be that every time a cluster is added, the like number of colors changes, which means that like our color conversion breaks. Yeah, yeah, that's a problem. We need to not. We just need to like pick a number here so that this color is consistent. It's important. Important. Yeah, okay. So let's get like kind of into the center-ish. And try to get a feel. So I think the pixel that we're looking at is actually up and to the right of the one that we're seeing move. Because I know it's like so small for you guys, sorry. Yeah, we're actually interpreting like here, not down here. Can we like color that thing somehow? I want to color the one pixel that we're looking at. So can we look at cluster out pixel at I don't know how to do this. Because, like, this guy is, like, a gradient value. And then we're turning that into this thing. So it's almost like this thing needs a, like, selected point. And then we can say, like, if it x equals selected point, if selected point, we have we have like sp for selected point. If this is equal to itx and the y is equal to ity, then we set the color to be something different. So can we just do this down here and do like color is equal to r equals 255 g, or maybe we do like blue, magenta, something like this. Then we can at least like see it. Fuck. Okay, so now we can look at, in the normal one, it's null, and in the debug one, it's clusterer dot itx clusterer ity. Yeah. Okay. Make this thing mutable. And then oh, no A. No A. Okay. Okay. I think if we put the step button above the image, then we can make it even bigger and see it, which would be kind of cool. Like if we put the stuff above the view, you know? Okay. Okay. So can we see the pixel that is being iterated? It's right here. Right here. I don't know if you guys can see that. Can I fucking zoom in? You guys see this shit? Step. Right here. Right here. It's this one. Okay. So as I'm stepping. Aha. I want a reset button. I want a. Okay, you can actually kind of see it here, right? What's going to be happening, I think, is like we're going to get to like here or something, and it's going to like bleed up. Oh, it did it there. It did it there. Okay, maybe what we should do is we should find a procedure that we can do, to like get to the perfect point. I think. So can we have like a reset button? Reset cluster. Reset cluster. Reset. And so this is just like cluster alloc reset, and then clusterer is equal to clusterer.init like this. And then update view here. Okay. So let's say we go to like 150, step 1, reset. 237, nah. 300, nah. That's getting close. Okay, so we'll say 500, step. Then, oh, I have to drag this so far to the left. Bad UI. Okay. Where are we, baby? I don't see anything happening. Reset. We'll go to 100. Click 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, here we go. 11 times at 100 brings us right here. Okay. 11 times at 100. Then bring this back down to fuck. Where am I? Bring this back down to 1. And just try our best to start seeing something. Oh, shit. Okay, we immediately see like a big color change there. That's hype. Okay, reset. Reset. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I brought it down to 1. Step. Okay, interesting. So what happened there? It filled in a hole. Why are there holes at all? To be honest, I feel like there shouldn't be holes. Can we, there's probably some, like, min value that it's looking at. Oh, it's just if cluster ID is 0. I assume it's this. I assume if we comment this out, we'll see a color everywhere. Yeah. Yeah, okay. Okay, so that means that, like, the whole is cluster ID 0. We are cluster ID 0. Okay? So we bring this guy up to 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we are literally right here. This guy on the right has not clustered yet. Okay. How does this guy have a cluster ID? This guy's matched with the guy to the top left. Ah, I think I get it. So I think that we move. I think that we come here. This guy matches with a guy below and to the right. Which means that then we have to merge this cluster because now all three of these pixels, which have never been seen together before, they need to like convert into one. Let's see if we can like see that happen. I moved by 100 again. My bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Bring this back down to 1 step. Surprisingly, no. I'm actually not sure, like, where that color change came from. We can actually get to this case easier if we just hard code this as hold on a sec. If every time we reset, we just run the thing 1100 times, we should be able to start like toggling back and forth. Yeah. Okay. What in the actual fuck is going on? Reset. Can you guys see that? I can't see what you guys see when I do this, but I think it's behind my camera, which is probably annoying. So maybe if I put it up here. We're just gonna have to hope for the best here. Step. Reset. Step. Reset. So who is like... Oh, it's that they're... I understand. I understand. Okay. We inspect this pixel here and this pixel here. Okay? These guys, totally chill. They are in a cluster together. Now, because we are looking here, we have never compared these two pixels together yet, right? We just haven't done that. Now, there's another time where we were here. I think. Here. We were here. And we compared these two pixels like this. So these guys all have the same ID because this guy's compared with this guy and this guy's compared with this guy and they're all the same. Now, we eventually come here and we find hold on. When we click next here, oh, it's one behind. It's one behind, I think. So we end up actually here. We end up right here. Okay? And we find that... Wait, one sec. Step. Yeah, so we just looked at this one. Reset. So these guys are the same. Yes. Okay, wait. We can get there. We can get here. Orange here. and here. Okay? Different color than red. Different color than red. And so when we are here, we find that me, can I draw it in blue? Number 1 here, 2 and 3, we determine that all 3 of these are the same fucking color. This is the sequence. That was really hard for me to visualize. But I think I understand. So it is like just a thing where, because you are not comparing every pixel in the box with every other pixel in the box, you have to like go through some center point in order to like match 2 segments that have previously been disjoint together. And so that is why we need to do merging. All of this was for me to say, why the absolute fuck do we have to merge at all? Right? I just didn't understand. Now it makes sense. There are just cases where like, because you're only correlating with the center pixel, or the top left pixel in our case, because we're actually looking at a thing that like, we're looking at this guy and looking to the right and down. Okay. Cool. So, what's the fix? How do we make this go fast? It's like, so if we do this scanning approach, we don't really have a choice, as far as I'm concerned now, in that you have to maintain merge lists, and you have to merge them together somehow. Which is obviously slow, because that's what we're seeing. We're seeing it be slow. Now, other options. We could do like a more traditional clustering algorithm, right? So we could pre-filter our points to have like, we could pre-filter our points to discard anything that's under some threshold, right? Then, so we like walk the list once to get all the points we care about. Then we do some sort of like more traditional clustering to pull them back together. So let me think. There's like hierarchical clustering where you can kind of just like have like some sort of heap where you pull like the minimum value over and over again. The minimum, like you take the 2 things that are closest together and you just like merge them over and over again. That still requires a lot of like merge list handling. Okay. There's also like, what is like DB scan, which we were kind of like basically loose on. What are they doing? They're basically doing they're looking at like stuff. They're looking at close by guys, and then they like union the sets, right? So they're kind of doing the same. Their cost is going to be relatively similar, where like set union is the thing that's being expensive for us, right? Okay. Sorry, I'm just still thinking. It would be sick if we just didn't have to get so crazy. I feel like looking 2 pixels to the right and 2 pixels down does feel important. I don't think that we can get away with doing 1 unless we have like a way to merge clusters that is like, if you have 2 big clusters, maybe like the search range is like allowed to be bigger. In which case I wonder if like hierarchical clustering is like a thing that kind of works better for us, right? It also solves this problem. So like as of right now, our answer is actually kind of like wrong. Fuck, hold on. I need to bring some of the coloring changes back. What did this look like before? Uh, yeah, this was just like this. Why do we have a ×1 in there? What the fuck are we doing? Does this come back to looking like... Yeah, there we go. Right, so like, using some sort of like hierarchical clustering would solve this problem where where things that are, how do I say this? Like these two disjoint clusters are like obviously the same fucking cluster, right? And the reason that we're not finding that is because our like search range is like is limited to being in pixel space, right? So we're like we only want to look for things that are like 2 pixels to the right or 2 pixels down. What might be interesting is if we were to say like as we get to 2 big clusters, like we're allowed to merge them from farther away. Now the typical hierarchical clustering thing is based only off of position, but we kind of have like a 3-dimensional thing of position plus gradient. So it's actually kind of like 4-dimensional. Maybe that being 4-dimensional makes it easier to... no, 3-dimensional is fine. Yeah. I actually don't know if our thing's completely horizontal. I feel like our angle threshold, I feel like this isn't doing the right thing, actually, now that I think about it. Because directions might be really large, right? This might be, fix me if 89 degrees, we should consider those close. Yeah. But that's fine. I'm thinking. So the way like the hierarchical clustering thing we've done in the past, say you start with like every pixel in its own cluster, then you like find closest pair. For us, this is like sort by angle difference. Maybe it's like sort by pixel distance, and then like threshold angle difference, which is not like an easy thing to just like have like a sorted list, right? When you have like pixels, right, you kind of have like, hey, these guys are close together, and it's like symmetric. I guess like with points, it's like their distance is the only metric you care about. Where if you have like angle thresholding as well, it's kind of like, I don't know, it seems like not obvious on like how to identify which pair of points to look at next, right? Like if you have like this with points, it's like obviously you look at these two because they're closer together, right? Like if you have like, you know, something like this, you would like look at this first, then this, then this. But when angles are involved, it's like, what do you do if you have like this, right? Like that's just like kind of confusing because now like you have you or even like maybe more interesting is like this, right? It's like, is this a better match or is this a better match? It depends on like the threshold, right? And so it's like you have like a per pixel, like a per point sorting of who you want to look at, which is not really ideal in this scenario. So keeping it like spatial is kind of nice in that way. If you, because like, also if you have, you don't want it to be like n squared where you have to check each point with each other point, right? You don't want to have to like track every single pair of points. That seems awful. I guess though you could do something where your initial cluster generation, you could like do a first pass where you walk the box around like this. You don't do any cluster merging, and you like generate your initial list of clusters by doing that. And then each cluster has an angle associated with it. And maybe like if the number of clusters is low, you can limit, you can then like build like your mappings of pairs of clusters or whatever. Seems kind of shit. The blur idea from earlier feels actually maybe kind of nice. Right, so you calculate the gradients, blur them, and kind of like by nature of blurring, like the magnitude of anything that is different kind of goes down. Right, so you could have like a filter step that's like increase like brightness of anything where I have guys around me with the same direction. Right, you could just run an image kernel over that thing that's like, I don't know if like a kernel works here, but like if you could have something that's like nearby within a 5x5 area, big number if all elements are similar. Small number if elements are different. This is just edge detection, no? This is just edge detection? But we're edge detecting, we're like doing like the gradient of the gradient or something? No, it's the opposite of edge detection. It's the opposite of edge detection. We want to highlight areas that are all the same. Which is just inverse of, yeah. So you do like 1 minus edge detection on edge. On edges or something like that. Okay. Well, One thing to keep in mind is that the barcode is gradient dense, but the directions are alternate opposite. I've fixed that though by limiting the gradient from 0 to 180 degrees. I just clamp anything that's on the going the other way. But you're right. You could take advantage of the oppositeness. You are right about that. However, I think that the oppositeness is kind of, it has to have that already for gradients to exist, I think. Right? Because there would be no gradient if there wasn't alternation. You know what I mean? So I think that that kind of comes for free. I think. Even if this works though, even if this works, we still lose like if there are like 2 potential barcodes in the scene, I think we still have to do some form of clustering. There isn't really a choice there. But you can do the clustering on an even lower res image. Yeah, I'll bet you there's something there. There's something there where like you just reduce the resolution again, and now the number of pairs of points that you have to look at is really small, but you can do that because you've already calculated the gradients. You only needed the resolution for gradient calculation. Yeah. So we can say right now, current problem is that the clustering algorithm is too expensive. We'll say cluster merging is taking a lot of steps in its current form. Could optimize hash maps, you know, like storage format, but that only will get us so far. You know, ideally, we reduce amount of work needed conceptually. Merge lists are necessary in current form. I would love to just try resizing the image down, like the gradient image, and then just run the existing fucking algorithm. Yeah. I think we can do that. We did image resizing somewhere. Where did we do that? Feed me. Here. Did we do anything crazy here? Do resize? We literally just like, it's literally just this. It's literally just this. Okay. Here's the plan. Here's the plan. We take our image gradient. We take the resize image. Like, can we even just like downsample image? You know, amount or like, yeah, divisor. I don't know, man. It doesn't really matter. I think we need an allocator. So we just go like, you know, make a new image. So T is type of input. We say T init alloc, I think it's input calc width and input calc height. Okay. Ret. I think this thing is failable. And we just go like 4. I guess we have like input integrator. While it next call, next row, we just like 4, or I guess it's like 4 while true, for 0 divisor, if it next row fails. I think we always do the first row, maybe? I don't know. Yeah. It's something like this. So this happens at the end of the loop. While it next call, we do this again on the end of the column. And then otherwise, we just say that, like, ret pixel at itx over divisor, ity over divisor equals it pixel. I think that's like kind of right. Something along these lines. I mean, I think this is like, maybe we should like pre-increment by divisor over 2 or something, but like whatever, you know? Okay, so now we can cluster init this thing. And we say like var resize is input downsample image input by like 3. And can we just use that? This is gonna fuck us up, actually. This is gonna be... Everything will work easier here if we do this here. Yeah, I think that everything will kind of work easier if we do it like this. And then I think everything almost just works. We should do some like linear interpolation or whatever. Oh, oops. Why am I just in the wrong folder? Hello? That's weird. What's going on? Yeah, true. This thing does need to be failable. U31 found U32, so divisor, we just set this to U31 and that fixes the problem, I think. Found this, so we dereference this pixel. Oopsies, I accidentally undid this again. He is unhappy because reached unreachable value. That's interesting. I wonder if this is like we're not hitting every pixel here. I'm an idiot. That should do it? No, not quite, but can we just not worry about this? What if we just like mem set this to... We must just not be copying perfectly. I just want to do this for a second, just to kind of make this happen. Magnitude Is it magnitude and direction here or something? What are the fucking numbers? Yeah. Okay. Not good. Not good. We've done something wrong here. While iterator, okay, let's just not do this for a second. This should end up being like a crop of the top left. Maybe we do it this way. We do return iterator, ret next row, ret next call, and we just look at IT pixel is input pixel from IT x times 3 divisor, ITY times divisor. That makes way more sense. And then this is the wrong size. This needs to be over divisor on both these. Oh, that's way easier. That's just like a way better way of doing this problem. Okay, now he's mad that there's like assertions at 1746. Can I just not fucking use the original? Yeah, let's just do this. This is not used, so we shouldn't use it. If we want it later, we can bring it back. Okay, here we go. So this is the resized thing. Why aren't we saying clusters anymore? Can I make this show up at all? Okay, here we go. We can get something here. Hold on. I don't understand why this min cluster magnitude changed now. Min cluster mag. Where is this used? Where is this used? If the gradient magnitude is less than this, then we skip. Yeah. Why is this value so small? If I'm resizing, I don't think the value should shrink. I don't think. I don't think. Oh wait, maybe we're okay. Here we go. So before we could get away with like a min cluster magnitude of something really large, but maybe we're just not seeing as many of those really high value ones because we're not like taking the max in an area. We are just picking at random, and so we're probably missing some of the really big boys or something like that. So maybe as we're downsampling, what we should actually do is take the maximum. I bet you that changes it. So we say like for input, like we do like input iterator is input area iterator. that starts at ITX times divisor, and it ends at ITX plus 1 times divisor. That feels pretty good. Then we can go like, you know, the maximum one. And we can say like, while input IT next pixel, max, if like, you know, input IT pixel dot magnitude is greater than max magnitude, max equals input pixel, then this guy gets set here. Yup. Okay. I think that kind of changes things. I think. No, I don't really understand why this threshold feels so much different now. But like there is something here. There is something here where, can we downsample by 2? We have got like our clustering down to like milliseconds, which is huge for us. Right? And like here, there is like a thing we can find, right? And also like our search range in the clustering can go down now from like the 2 pixels in each direction. We should really only need to look 1 pixel in each direction now. So there's like an improvement there as well. Like here. Right, like there's something here. Right? There's definitely something there. And now we're down to like 25 milliseconds with a 2 times downsample. If we do a 3 times downsample, we can probably get somewhere pretty good as well. Either way, this is like this is like actually usable in terms of like, what was this? How do we fucking... Yeah, with a 3 times downsample, it's like pretty sketch, I think. And then I think also probably our angle merging is like not quite correct because whatever, but there's something here. There's something there. So maybe we like increase the resolution of the initial image a little bit, then downsample more for the clustering step because the gradient calculation is like relatively cheap. There's something there. There's something there, but yeah, I think it's a win. I think this is a win. Cool. Doing less work makes things easier. Who would have thought? Who would have thought? All right, cool. It's 4:30. It's late. I'm gonna call it there for today. Thanks for watching, guys. If you like what we saw, we stream most days. We aim for around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 now. So anywhere between 4 hours ago and now is when you should expect to see us live. We're kind of like working on this barcode scanner right now as like a side quest on our image editor, or not our image editor, my brain, on our meal tracker. But there might be more side quests coming. There might not. We're hoping to get this done soon, but you know, it is what it is. There's a YouTube link in the Twitch description where we post, you know, some subset of all VODs, right? Maybe some of today's VOD goes up, but definitely not the whole thing. The metric is essentially, if I think it's something that is like clickable, it goes there. If it's not something that can go on the YouTube, it ends up on Patreon or in Twitch VODs or on like YouTube member segment. You have to pay to get the rest of that stuff. But the return is, if I don't run out of money, I continue streaming. right? So if you want to support the stream and get access to the stuff that doesn't get posted on YouTube for later viewing, please consider supporting on whatever platform makes sense for you. But obviously no pressure. Yeah, I don't think that we have to plug anything else. Let's find someone to raid. Thanks for watching.